Max, move your head.
Okay, what you know that is in equilibrium position, the pressure on this side is equal to the pressure on this side. Because otherwise we would be in equilibrium. Well, the pressure on this side is going to be rho GH plus atmospheric pressure, because it's open to the outside. Pressure on this side is going to be rho GH plus atmospheric pressure.
Almost. Easy so far.
Okay? Well, the atmospheric pressure is the same on both sides. So on this side, rho GH for water has to equal to rho GH for mercury. And that's the way you set it up. We've got numbers here. I know that my pressure for the water is rho GH, where rho is 998 or 1,000, G is 9.8, H is 20 centimeters. Okay? That's got to be equal to my rho GH for the mercury. So when you substitute solve for this, you get 1956, which is equal to the density of mercury, which is 13,600 times 9.8 times H. You get H equal to 1.5 centimeters.
That's the entire answer.
Which means that this distance here
Where do you get?
is 1.5 centimeters.
Look here.
So this distance here is going to be 20 minus 1.5, which is 18.5. In other words, this right here is the same as that right there. The rho GH of the water is equal to rho GH of the mercury. But because the mercury is so much denser, you don't need much height to equal the density, the pressure you get from this one with a much larger height. Then for number 18, what's pushing, when you have a siphon, what is pushing the fluid through the siphon is air pressure.
All the videos look the same, just different scribbling.
Okay, what you do is you empty out the tube, okay, so that, and then what's pushing the air through the tube, in other words, you get a vacuum here, so there is no atmospheric pressure. You do have atmospheric pressure here. And that atmospheric pressure then pushes the fluid up and through the tube. And then once the fluid starts flowing, because liquids tend to stick together, this part kind of drags the rest of the part up through the tube and out. So your atmospheric pressure is then equal to your, if you got this pressure here equal to your atmospheric pressure, then that's where the fluid would stop. But so long as the atmospheric pressure was less than this pressure, then the fluid will flow. So your atmospheric pressure, rho GH, or in this case your density is 1,840. So for H comes up as 5.6 meters. If this were more than 5.6, then the height here would be equal to the pressure here, and it would not flow. But so long as this is less than 5.6, then the pressure on this side is less than the pressure out here, and the fluid will flow through. Okay? Questions?
No, it hurt me.